26. Today we present our reproduction and extension of one-shot RLVR. Reinforcement learning with verifiable rewards typically needs large, high-quality datasets, but recent work by Wang et al. Show that RLVR can be conducted with a dataset consisting of just one example. Primary discoveries of one-shot RLVR show that results comparable to full-size datasets, generalizability, and learning even after training overfit. Our study aims to explore two directions based on the original paper. While Wang et al. Highlight the importance of the selected one-shot example, the optimal criteria for selection remains unclear. A question also remains of whether the model is learning to solve the problem or better format the answer for correct parsing. Can results be improved through varied reward functions that focus on problem solving? We select our one-shot examples from the subset of DeepScaleR dataset. Training is then conducted over a dataset consisting of 128 copies of one example. Validation and evaluation are both conducted over the Math 500 dataset. Our main goals are threefold. First, we re-implement one-shot RLVR on the Quen 2.5 math model with 1.5 billion parameters, copying what was done in the original paper. We then experiment with two types of data selection methods. We conduct training over the subset of DeepScaleR and select the example with the highest training accuracy variance. This is the same as the original one-shot RLVR paper. And then one with training impact most similar to the model's training curve. This method is taken from LIMR. This gives us two datasets. We also test several reward functions to understand what kind of signal helps the model improve. The simplest is correctness only, which rewards the model strictly for providing the right answer. We then add small bonuses or penalties for formatting, since RLVR relies on boxed answer formatting to verify responses, to see whether rewarding or punishing the correct formatting but incorrect answer gives better results. Finally, we test a formatting-only reward, which ignores correctness entirely to see how much of the model's performance is because of improvements in formatting. Our overall workflow begins with the two data selection method at the top. Each method chooses a single problem, which we then duplicate to build the one-shot RLVR dataset. We train the Quen 2.5 Math 1.5b using the RLVR pipeline, sampling answers, verifying them automatically, scoring them, and then applying policy updates with cross-entropy KL regularization and reward signal. Finally, we evaluate each setup based on the Math 500 dataset, comparing both the final accuracy and the quality of the model's reasoning. This lets us isolate the impact of data selection and reward design. First, we replicate the original one-shot RLVR setup. The base model starts at about 33% accuracy on Math 500, and after one-shot RLVR training, it reaches 68%. This confirms that one-shot training signal alone can substantially shift the model's reasoning ability. For data selection, we observed that swapping the one example leads to noticeable performance differences. Variance-based selection performs better than learning impact-based selection. The learning curve gives us an idea of why that is. The question with the highest learning impact is actually simpler than the variance-based one, making the task too easy for our model. We also experiment with different reward functions. Significant performance improvements are owed to the model's learning to format. Rewarding correct formatting actually improves the model's performance over the correctness-only approach. In conclusion, we verified that simple RLVR setups can meaningfully boost LLM reasoning without large compute, offering a practical path for applications like tutoring systems, verification tools, and math-focused AI models. Our explorations show that data selection performs a significant role in one-shot RLVR learning. Variance-based selection performs better than learning impact-based selection. Formatting learning is a significant contributor to the improved outcomes, and encouraging the model to format correctly produces better results. Thank you.